Okay guys, so I hope this is close enough, but I want you to get an overall picture of what's going on. So for 8.3 for honors, 6.3 for math 7. Okay guys, we're making comparative inferences about populations. In other words, we're going to compare two sets of data. Okay? And it says, how can you use data displays to compare populations? So today we're going to focus on the box and whisker. Okay, so here's what we're looking at. There's a few things I'm going to look at right here, and that is over on the side here. I want you to write this down real quick. We've got the median, which I explained. The median, the range, and the outlier. I put definitions in on the last lesson, so you should be able to look those up. The one that we're going to add here is the interquartile range. Okay, interquartile range. And I'm going to show you exactly what that is, but the main thing you need to remember is it's the median 50% of the population. Okay, and I'm going to show you how we're going to be able to graph that with a box and whisker. Okay, so here's what we're looking at. So hopefully you can see this. Now, this is based off of example 3. We have all this data, okay? And this is what we're talking about. I've got Finn and Jonah, and they went through and they talked to 20 different students each at each of their schools to find out how much time they spent doing homework each week. Hours of homework per week. Okay, guys? Now, if you notice, Finn talked to these 20 different students, and I set these all up in order. So Finn's got 1, 2, 3 hours, 3 hours, 4 hours, 4 hours, 4 hours, 4 hours. Obviously, they didn't come in that order, but that I put them in order so we could see where the median score is. Okay? Now remember, there are 20 students. So Jonah did the same thing, and you can tell just by looking at this, his hours get higher right away. And so our hypothesis here is, or our theory, is that on average, Jonah's school puts in more hours of homework per week. But we're going to prove that. Okay, guys? Okay, so the first thing we need to do is we need to find the median. Now, if I have 20 students, then we know we need to count 10 in. Because it's even amount, we're going to have to count the middle two numbers, okay, and then take the average between them. In other words, when I count in 10, so we'll use Jonas as an example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 is here, and then 8 would be 10 from this side. Since it's 6 and 8, between 6 and 8 is 7, or you would add 6 and 8 together, which is 14, divided by 2 and get 7. So in other words, our median is 7. Okay? If we do the same thing, then the two numbers that are at Finn's school are 5. They're both 5. If we add the 5s together, we get 10 divided by 2 is 5, or we should know that the median here is 5. So obviously right here, we're seeing, just based on the median number, which is higher for Jonah's school, 7 hours, is greater than the 5 hours for Finn's school. Okay, guys? Now, then we need to find, so we can form the inner quartile, we need to find the median of the lower quartile, which is the lower numbers, and the upper quartile. So we're going to find the median between that. Since we have 10 numbers, in other words, it divides right here to find these lower quartile median and the upper quartile median. We divide right here, that's 10. I'm going to go in 5. So 1, 2, 3, 4, 5. And then I have to go in 5 here. 1, 2, 3, 4, 5. It's 3 and 4. So my lower quartile number median is 3.5. And you're going to see where that comes into play when we graph it. For Jonah's school, it's 5.5 because it's 5 and 6. Okay? The upper quartile, we do the same thing. In other words, we've got 10 numbers in the upper quartile because it's from this point right here, right? And so when I do this, I'm going to count in 5. 1, 2, 3, 4, 5. There's 6. And then in 5, 1, 2, 3, 4, 5. The median between 6 and 7 is 6.5. And then I have the two 8s here, so that's 8. Okay? So first thing I'm going to do is we're going to graph fins, okay? And so fins is, I'm going to write fin here. Now what we need to look at is the range. Okay, so first of all, I'm going to mark each of these medians that we found. So for fin, 3.5, so up here, 3.5, I'm going to go like this. I'm going to put a line, okay? That's approximately at 3.5. Then I'm going to put another line at 5, so I'm going to go up to 5 and put another line, and you're going to see why I'm doing this, okay? And then I've got one at 6.5, and I'm going to put another line. Now this becomes the box. This is the box. Right here shows the median, okay? That's where the median is, okay? And then this is worth 50% of the population. 50% of the population lands in here. But we need to include the whole range, and this is where the whiskers come in. So in other words, what I do is I look at the lowest number. It's 1. Do you see that? So what I'm going to do is I'm going to put a line at 1, and then I'm going to draw a line, and it's like a whisker, okay? This is going to show, this is the bottom range. But we need to show the complete range, and if you see over here, the top number is 11. So I'm going to draw an 11 here, okay? And this becomes the top range. So that is a complete box and whisker. 50% of the population is here. The lower 25% of the population is here. And the upper 25% of the population is here. In other words, the upper 25% of the population is from 6.5 up to 11 hours of homework per week. Okay, now we're going to go through and we're going to graph Jonas. Okay, so Jonas, we look and the median is actually at 7. So I'm going to draw a line at the median. See, that's 7. We've got the upper quartile median, which is 8. Then we got the lower quartile median, which is 5.5. Okay, so now I'm going to draw the box here. Notice how these boxes are pretty close to the same width. Okay, if they're pretty close to the same, then we know the variable doesn't change that much, okay? Now we're going to look at the range. Hey, this one starts down here at 1. Okay, so this is 1, and then I'm going to draw a whisker here, okay? And again, this is also 50% of the population, okay? And then this actually goes up to 11 also, so I'm going to draw that, okay? Now, from what we can tell, we know based on what we've seen so far, that it looks like Jonas School spends much more time doing homework. But we're going to prove that to be correct to make sure we don't have any like big time outliers that are affecting this too much. So in other words, the one thing we want to look at is the variability. Okay? Now the first thing I want to look at is first I want you to see this. These lines right here, they represent the median. So the median is represented by the line in the middle of the box, okay? Then we have the range. The range goes all the way from one whisker to the other, okay? In other words, from 1 to 11. The range on both of these is the same, which helps our data to be more accurate. Okay, the range on both of these is from 1 to 11. That means the range for both of these is 10. The 10 range from 1 to 11, we take 11 minus 1, the range is 10. Okay, 10 hours worth of time is the range. Okay, the outlier, when I look at this, the outlier is the number that is furthest from the median. Since this median's at 7 and the first person only spends an hour, this right here is definitely my outlier because 1 is further away from 7 than 11 is further away from 7, okay? Because this is only 4, right? There's only 4 away from this. This is 6. The main reason we're looking at that outlier more so is because we already have a hypothesis that this would be the one that has the greater amount of hours worth of homework. Okay, guys? Okay, so that might make it contradictory, but we're going to prove it, okay? So the way we're going to prove it is variability, to see if the variability is that much different. Now the variability only is based on the 50%, in other words, the box of each of these. So I'm going to label these so you can see it where the variability is. Okay, so we already know these boxes are worth 50%, so I'm going to take this off so we have room to write. Okay, guys? Okay, so this right here is 3.5. Okay, this is where this is at 3.5 hours, okay? The top is at 6.5 hours. That means if I subtract 1 from this, the variability here is 3. 6.5 minus 3.5 is 3. Okay, so that's just our variability between our median 50% of the population. Now, if this isn't much different than this, then we know that this is more accurate, that these are accurate predictions, okay? So in other words, when I look at this, this is 8, okay? So in other words, 8 hours of homework, and this is 5.5. If I subtract 5.5 from 8, I got 2.5, which is really close to 3. That means the variability of the median 50% of the population is pretty close. That means the numbers we have and the graphing we did is pretty accurate. So if you look at this, these are the same, right? In size, pretty close the same in size. That's what that variability is representing. How different are they in size? But since the median 50% is further along, they're higher up in here, that means that Jonas School, they spend much more time going through and doing homework. Okay, guys? So I know it may be easy to see, but the more data you have, and they always say a picture's worth 1,000 words, the more data you have, the easier it is going to be able to prove it. Okay, guys? Now, if you don't understand some of this, make sure you ask in class. There's going to be a lot of questions on this as far as the box and whisker being able to interpret it. They're not going to ask you to draw it, but they are going to ask you to interpret it. So make sure you ask questions if you don't understand it. All right, guys. Good luck.